Each technique that is currently used to successfully detect extrasolar planets with the mass of Jupiter or larger could eventually and potentially be used to detect terrestrial planets or Earth-like objects. The direct detection technique is very difficult for Earths. The Sun outshines Jupiter by a factor of 1 billion, but the Earth by a factor of 10 billion. The way to improve this experiment is to move into the infrared, where the contrast improves by a factor of 1,000. A transit experiment can also be used. In an edge-on orbit, Jupiter would dim the Sun by 1% for 1 day every 12 years. An Earth, being 10 times smaller, would dim the Sun by 100 times less, or only 0.01%, a tiny effect. The Doppler effect that's been used successfully to detect most extrasolar planets discovered so far requires extraordinary sensitivity if it's used to detect Earths. The Sun pivots about its edge caused mostly by Jupiter, and so the detection of Jupiter requires a velocity precision of 13 meters per second. Detecting an Earth with this technique requires a precision of 0.09 meters per second. Finally, the gravitational lensing technique, where brief magnification of a background star is caused by an intervening planet, can be used quite well to detect Earth-mass objects as well as Jupiter-mass objects. All of these techniques have an interesting prospect in the next 10 or 20 years. To succeed in detecting Earths, probably they will have to be experiments done from space.